Hello and welcome to our lesson on inequalities. There'll be two lessons on inequalities. This first one will deal with what we call simple, and then we'll do some compound ones. Our goals for this lesson are to review what inequalities are and then move on to solving simple inequalities. That'll be similar to solving an equation, another rule change in there for it. And then looking at a visual, a number line, and an equation, or an inequality I should say, so that we can do converting between the two forms. So here we go. Should all be review. An inequality is a symbol representing the relation of two values, similar to an equal sign. Solving an inequality can be difficult because the answer will include more than one value. We like saying x equals 2 or x equals 5 halves, but here we're going to want a range of values, more than one. So the symbols that we'll get familiar with, you probably already know what this is. It is a less than. If we were doing a number line, we would see that it draws a line facing left, or in many ways you can just look at the direction of the symbol. It points to the left. And in this case, since there's not an underline for it, it would have an open dot when we graph that. For less than or equal, it also goes to the left, but instead of an open dot, it would be a solid dot. This symbol, greater than, would draw an arrow to the right and would be open because it doesn't have an underline, the or equals part, and then this one is greater than or equal, going to the right, and it's solid. So in practice, we would see these type of images, and that's what the open dot, solid dot, left and right will be. Okay, I want to quickly give you a little visual here that you can draw quickly and have it as a reference on a test, whatever, but you have to come up with it. But basically, left and open dot, left and solid dot, right, open dot, right, solid dot. So if we wanted to write the inequality that goes with this green one, we would write x is, and the arrow goes to the left, and it's a solid dot, so less than or equal, and then the number is -3. Looking at the next one, the black one, we would notice that x in this case goes to the right, and it's an open dot, and it starts at -1. And then last, x is greater than or equals 2. Okay? Here we go. Graph each inequality. So here's the inequality. Now can you make the graph? The first one, we're going to start at 7. Recognize that the dot includes the value 7. So we're going to fill that in, call it a solid dot. And you can think of it as the arrow pointing to the right, or greater than or equal, always go to the right. So we put a dot filled in and then an arrow to the right. Once you try number 2, you can hit pause. Okay, for number 2, we're going to go to the 4. There's a dot that's open, not filled in because it's not or equals, and it goes to the left for less than. Why don't you try 3, 4, 5, and 6? I'll give you the answers and then you can check and go back and make sure that you understand the concept. Okay, here we go. Greater than -5. Start at -5, open circle, goes to the right. X is less than or equal, so it's going to be filled in to the left, starting at -2. Filled in and less than, values that are less. This number 5 is a little bit confusing because the X isn't on the left side. We really like to have the X on the left side for reading and for just intuitive answers. We could say 0 has to be greater than whatever the value of X is. So if 0 is greater, it means that all the values have to be smaller for X. In order to get the X on the left side, all we do is have to flip and flip the direction of the inequality as well. We would say X is less than 0. 0 is greater than X. X is less than 0, and sure enough, that's the graph. All right, now let's do our last one here. We'll flip and flip the direction of the inequality. We'll say instead of -3 less than or equal, we'll say x greater than or equal, and then the -3 will go to -3, or equal means we fill it in and it goes to the right. And we can evaluate this. If I pick a value that is somewhere along this line, for instance 1, and plugged it in here for x, is -3 less than or equal to 1? Sure it is. In fact, all the way down to -3. Okay. Sometimes a variable is not isolated and we need to solve it like an equation. Solving an inequality involves the same skills as solving an equation with one exception. Whenever you multiply or divide an inequality by a negative number, you must flip the direction of the inequality. The way that shows itself is this one does not have a negative, but we do have to get the x by itself. So we get x is greater than 2 divided by 2, which is 1. And you can check your answer here. Pick a number that is greater than 1. Let's say 5. Now plug that in up here. Is 2 times 5 greater than 2? Sure, that solves the inequality in simplified form as well as in the original equation. Now when we go over here and divide by -2 because of the coefficient of x, if you didn't think about it, you would write x is greater than -1. And you could pick a value that's greater than -1. For instance, 0 is bigger than -1. If you plugged in a 0 here, you would get -2 times 0. That's 0. 0 is not greater than 2. You need to flip the direction of the inequality. So in this case, x is less than -1 would include values like, let's say, -2. If you plug in a -2 here, -2 times -2 is +4, and sure enough, 4 is greater than 2. So whenever you're solving an inequality with a negative coefficient, or a negative being multiplied or divided to solve, you must flip the direction of the inequality. Now when we're graphing these inequalities, what you'll notice is these are two-step inequalities instead of just solving in one. And for one of them, I do have a negative to deal with, so I've got to remember that, flipping the direction of the inequality. So let's get started. If this was an equation with an equal sign here, we would simply undo the addition or subtraction and then the multiplication. Same idea here. Undo +8 with -8. Undo multiply by 3 with divide by 3. And I'm going to do the flipping. So my x is now on the left. I flip the direction of the inequality because I've moved x from right to left. And then 3 goes into -15, -5. So with a number line without any values, I just think to myself, negative numbers are going to be to the left, so I move my 0 a little bit to the right. Call this -5. Open circle goes to the right. This next one, give that one a try. Notice there is no negative exponent, or sorry, give this one a try. Notice there's no negative coefficient, so you won't be multiplying or dividing by a negative. But it is two steps. Go ahead and get started, and then I'll work on it. Okay, we're going to add 14, and then divide by 3. In this case, x is greater than 5 again. So, okay, x is greater than 5. I'm going to put my 0 a little bit to the left. I'd have a 5 up here. Greater than is an open circle, and to the right. This last one could be a little tricky just because of the negative. I point that out. Go ahead and get started and see how it goes. All right, subtract 7 from both sides. And then divide by a negative. What that's going to do is flip the direction of the inequality. Even though I didn't flip the side of the x because of the dividing by a negative, I get this, -2, and it's going to be less than, it's an open circle, and to the left. And it might be worth just quickly going through and verifying these all work. If I picked a value somewhere in here, I could pick a number like -2. If I plug that in, I would see that -7 less than 3 times -2 plus 8. -7 is less than -6 plus 8 is less than 2. And sure enough, negative 7 is less than 2. That's true. You might want to try plugging in a value that should not work. For instance, if I plugged in a value like negative 6, if I tried that, I'd get negative 7 is less than 3 times negative 6 plus 8. And that means negative 7 is less than negative 18 plus 8. Negative 7 is less than negative 10. That is not true. So verifying one answer as correct is good. Verifying that an answer that shouldn't work is also good. All right, you can do that with these just to make sure. Now let's look at some complicated inequalities. Slightly more difficult solving is involved, but it's really similar. You've done it with equations. These are just inequalities. I'm going to combine my like terms. I get 6x plus 21 less than negative 15. Subtract 21. And I get negative 36. Notice this 6 is positive. I'm not dividing by negative, even though there's a negative on the right side. So I will not flip the direction of the inequality. Come down here, negative 6. There's my 0 as a reference. Put an open circle to the left. You can check that answer to make sure. Come over here. This one's annoying because I've got x's on both sides as well as constants. I'm going to subtract, and this is a 1x from both sides, leaving me with a 5 is greater than 2x. Notice some kids, for some reason, when they subtract x and there's no number in front, they just like cancel it out. Make sure that you keep the coefficient there. And now this looks like a similar inequality we've solved earlier. So I get x is less than 3. And because I had to flip the direction there, I'm going to go ahead and graph it and then pick a number to make sure it works. So if this is 0, here's 3, open circle, smaller. Easy number to plug into test is 0, so let's try a 0. 0 plus 5 is greater than 3 times 0 minus 1. 0 plus 5 is 5. 3 times 0 is 0. 0 minus 1 is negative 1, and 5 is greater than negative 1. So that looks good. Some frequently asked questions, and then we'll do your on your own. How do I know when to flip the direction of the inequality? If you have to multiply or divide by negative, or if you are getting the variable on the left side from the right side. So if you flip the whole thing, you have to flip the inequality as well. Should I flip the direction of the arrow when I go to graph my solution? Don't. Only flip the direction of the inequality, then graph that inequality the way you would even if you didn't have to flip it. How can I remember how to start solving an inequality? Think of the inequality simply as an equation and solve for x. The only difference is covered in the earlier questions, basically that flipping the direction. And then what if the variable is on the right side? We talked about that. Flip the stuff on the right over to the left, vice versa, left over to the right, and then remember to flip the direction of the inequality. All right. On your own, give these a go. Try to graph the inequalities on the left and then try to find the inequality from the graph on the problem on your right, and we'll see you in class.